Let us try to understand some basic of printed circuit board and PCB layouts. You can see here one of the PCB which have been designed. Let's try to understand more about PCB design. Let us try to understand different soldering pads of having different size. When we come to sizes, you can see from left to right, it goes from small size to big size. That is from 3.8 mm to 12.7 mm. Okay. Again, there is one more thing you have to note down. The internal circle, or you'll see the diameter will be different and the external diameter will be different. So these pads can be off as per your needs. Okay. Let's go ahead. If you see the soldering track lines or the conductors in the PCB can also have a different size. If you see from top to down, it is 0.5 mm till 8 mm. Now, as per requirement, you have to use the size of track. Okay, like for example, you want to make thick earthing, it could be 8 mm or it could be something 4 mm, and the track line can be other things. Okay. The other pads can be, for example, transistor can be done this way also. Left hand side and right hand side both are okay and fine and perfect. Let's go ahead. The connector pad you can see of different sizes and different looks also. This is just the pad which you can get in market and use to complete your PCB design using such pad, or you can do by using any other method like paper pen and then taking permanent markers and etc. Well, then for ICs, again, you see, as you know that all components size should be fixed, perfect and right when you're designing a PCB layout. So you should know the size of IC, whether it's a 4-pin, 8-pin ICs, and distance between each pins should be known. So that is how we can design it perfectly, rightly. When mount on the PCB should be right. Okay. So from the left, you can see we have the 8-pin IC, and it goes to the 16-pin IC at the rightmost. Okay. Again, you see here the other ICs could be also in different forms, like we are circular, all that. So all care has to be taken. Size between the or distance between each pin should be known very well. Again, if you see the left hand side and right hand side, we have two things to note down. One is not recommended, one is recommended. So left hand side is a not recommended, right hand side is a recommended. What are those? Okay. If you see the left on the top, the track which has been designed there, this is not recommended. Okay. Now what could be the reason? Let me zoom out and see. Okay, this is the thing, is not recommended, but you could have the like this. Okay, recommended on the right hand side. So track comes, but the soldering pad is little bigger in either cases. Okay, so that is, they say recommended, and the size also mentioned. If the track size is 1 mm, the size of your track could be approximately 3 mm. Okay, if size of track is a 1 mm, the size of the soldering pad, that is circular one, can be 3 times, that is 3 mm. Okay, similarly, if we go ahead, see solder pad diameter and the conductor, all this we have seen. Now if you see down left hand side, okay, it's not recommended. While design you could take care of this. Okay, this is not recommended, but this is both are the same part, but this is how you can do. This is not recommended, but this is okay, fine. Okay, even this is not recommended, but this will be nice. Similarly, we can go ahead down. Okay, so left hand side here is not recommended, but this is accepted. Similarly, this could is not acceptable or not recommended. Okay, some people do it, but it's not recommended, but this is recommended in the place of this. I hope you understood these recommendations of different pairs, how it can be done. Let's go ahead. Similarly, if you see here, we have the left hand side tape joining or pairs. Sometimes we make mistakes while doing this. What is that? I'll zoom and see here. This, if you zoom and see here, you understand there is a gap here, right? The small hairline gap. Here, if you see here, there's no hole here, right? Or the inner center is not missing. So it should be corrected, and the fine perfect will be this one. You can see here, correct one. Okay, the size, everything is taken nicely. Size of track and size of soldering pad are proper as per design. You can have tape joining in this form, left hand side with the round bend corners or cut corners. Cut corners look descend. Cut corner means normally it is 90 degree. Okay, either we can use it to do this. Okay, nice will be if you take the cut corners. It looks very decent and nice. Yeah. Okay, let's go ahead. Even when come to the mounting of transistors, if you see the left hand side, these are not recommended, right hand side is recommended. So this part, you see, resistance is little up, okay, while mounting, but in the right hand side, if you see, it is touching the body, maybe with a very fine graph, so this is recommended. And similarly, sometimes we don't get enough place, so we do the vertical mounting of component. However, so you see here in the left hand side, okay, in left hand side, it is touching the body, okay, because this should not be avoided. This is okay, okay, touching the body, but this way the body should not touch the PCB. That's why you could have some gap like this. You can see some gap here, so this is recommended. Similar for capacitor also, you see this is there, and the gap which is just touching the body is touching the left hand side. If you see very clearly, okay, it is touching the body here, where here there is some gap. You can see a little raise above the PCB. So these are the recommended of the recommended and not recommended. Left hand side is not recommended, right hand side is recommended. Okay, so similarly, if you see here, you have transistor mounting here. Left hand side not recommended, right hand side is recommended. Again, what we did there, the same thing is applicable here. The polish is touching here. Here we have kept some gap with some resonance failure or some gap. Here also see we had kept a space, but if you keep a good space, then it's good nice to keep a sleeves, okay, some sleeves. So either way we have to do it. Similar for transistors, a bigger transistor. See, it is touching, the body is touching, which should be avoided. Rather than should be raised, and some spacer or something space washer can be fixed up for the bigger transistors. Okay, I hope you understood this. Let's observe a circuit drawn for PCB layout design for a given circuit using PCB Droid software. Later on, we'll use the same software to design a PCB layout of our choice. Let's draw a PCB layout of a given circuit below using PCB Android mobile software. Okay, let us try to draw the PCB layout of given circuit. So we can mark some points in advance and then join, or you can join in the phase wise as per your convenience. Marking all the points, it actually become easier. However, sometime you have to modify. So we'll just go ahead. So I'm marking one point here. So in between these 2 points, I shall connect a resistance R1. Okay. So I join this. We'll go ahead. So I label this R1, which could be labeled anywhere here. So R1. We'll go ahead. Between these 2 points, see, I'm trying to connect a capacitor. Okay. Here I'm trying to make a provision for transistors, which are 3-pin leads. Okay. So and then some provision for resistance. Okay. Okay. So we'll join them after doing this. This is another point. You see, it is your choice. You can mark all points. You can do phase wise. I'm trying to mark the points now. If you can remember well, you can mark all the points and you can do phase wise also. So I'm making all these things to make you little bit easier. Okay. Now in between this here, okay, I'm connecting the resistance R2. I hope if you see the circuit, you will understand how we have done it. So okay. So I connected. This go for your whatever supply, whatever you have it. Now let's go ahead next. So I'm going little down here for next resistance R3. You see, this is a provision made for resistance R3. Okay, then we join it. This is a transistor which are connected here. Then let's go ahead. Okay, we'll mark points here. This is the base of transistor. We'll go to one more resistance. See, this we are making provision for. Okay, resistance. And then we are going ahead. For emitter of the second transistor goes to the negative supply or to the earthing. You see, we can make a track like this for connecting supply, or they can make. So here we have so many points to connect for the 2 points for the supplying positive, 2 points for the negative supply. Not necessary, but if you could make, you can make it. Okay, this for plus of VCC, and you can mark a minus for the supply here of the battery. So we'll label the capacitor C1. I just increase the font size just for, you can increase the size of font as per your choice. Okay. Okay, see, this was the mistake here. This track I removed from this track. It's supposed to be a resistance. We have just closed it, so we'll remove this track. Okay, so this is for resistance. So R4. Okay, I hope you are understanding. Now this is what's left, so I can take a track between the transistors as I shown you. You can connect the way you want it also. Okay, this for your understanding. Otherwise, practically we have completed your circuit. I hope you understood. Well, normally we take this, this is the front view, how the after mounting look like printed on circuit board. But normally we take a print of back view. We have to take back view of this. That is what you can mirror image you can say, and whatever you can say. You can do either by using carbon while drawing with hands and pencil and rubber, etc., or using permanent marker, all that. Or else you can take a print while inverting. So while saving it, you could go to image, and you see this is how your PCB look like. Okay, so either GPG, which format you want, you can do it, and you can always do inverted or the image. Okay, you see this is how the image will look like, which we need to print it on the your printed circuit board. And what is done, then it is done. Okay, after because when you do on PCB, actually first you draw the PCB layout, back view, and then you can label it, so that become easier. Otherwise, I can see the lateral image can see on the PCB design. I hope you understood this. Now we'll try to draw a PCB layout using a simple IC, 8-pin IC. Let's try out. Let's understand orientation of IC. So we'll follow the pin numbers from here. It goes to here. So this is the order from the dot 1, and this will be pin number 8. This will be a 4, and this will be a 5. Similarly, the order will follow same thing, 1 to 8. Okay, this will be pin number 1, and this will be 8, and same we can follow from here to here, pin number 1 to 8. From dot we are going to start, and up here pin number 1 to 8. So let's begin. So I just marked the earthing strip and IC is ready. So we'll join this pin number 4 and 8 shorted internally, I see in the diagram. Thereafter we'll put one more power line that will go to VCC. Okay, then we connect this 4 and which has been shorted, we given to VCC. So we completed 4, 8 and VCC supply. Let's go ahead. So pin number 1 go directly to the earth or the grounding. You see it's been grounded. Then we take now we'll mark some points so that we can join those all points. Okay, so we are making little provision for all. This is for pin number, okay, one of the resistance we can connect here, or pin number 5 you can see here. Pin number 5 goes to earthing via capacitor. Okay, you can see this is for the capacitor. Okay, via pin number 5 to the earth or grounding. We'll go ahead, then we'll take some tracks. You see 6 and 2 are shorted, and the resistance to connect between pin number 7 and VCC, and between 7 and the 2 shorted point of 2 and 6. So we have to take care of it. So okay, let's say pin number 2. Okay, this way will short and take. So you can take the tracks between the capacitor, below the resistor, transistor, IC, etc. But caps taken should not short. Okay, so see, connected to pin number 7. Okay, okay, pin number 6 and 2 have been shorted. Now we need to connect the next resistance. You see, it can be done like this. So one of the, I'm making a provision to connect the resistance here. So one resistance connected between the pin and 2 shorted resistance. One more resistance will connect between the pin number 7 and VCC. So we'll go ahead. These are connected. See, and you can take the output there from here. So here we are connecting a resistance here. Okay, so that is between pin number 7 and VCC. Let's go ahead. So we are making some provision for supply line. You can remove this part also if you want. You can remove this part. Okay, this part remove, or you can keep it, up to you can decide. Otherwise you can just remove the track while doing the final things. Okay, so now we are making provision for supply, C plus and minus. Okay, this will go for supply, and then we have for the, this go to earth. Okay, this actually complete your circuit using, as your labeling part we have not done here, just to save your timings. Okay, if you want to make your earthing little thicker, you can do this way also using the software. This complete your the IC given your circuit diagram of PCB layout of the given circuit. I hope you understood. Okay, as informed you earlier that we normally print on the PCB, that's a print circuit board back view. This is the front view. You have to always draw back view, or print, take a inverted image, or you can say mirror image of this, and then you can take a print on the and then paste on it, or you can draw with using carbon paper and etc. System see that it is always a back view of your PCB layout. So let's try out. So this is how front view look like. You can see in the diagram, this is how actually front view look like. after taking all measurements right and perfect. This was just taken a demo. Then you can go back to the your see inverted. If you do, it will be like this. Okay, if you do mirror, it will look like this. So you know to remove. This is how this is what we actually have to draw on your PCB, and for then we send for etching and unwanted copper is removed. Then you drill and mount it. Okay, I hope you understood.